everyone. Thanks for coming to this session. So the previous session was all about enabling technologies. This is going to be a bit more about methods, which everyone loves. But I'm going to try to make it very appealing. So if you're working in R&D, hopefully this talk is going to be meaningful for you, even if you're not a VR or AR researcher. By the end of the talk, also hopefully this title will make some sense. What are immersive speculative enactments? And hopefully you can use them in your own research. Can I get the timer on the bottom? Is that okay? Just so I can make sure I'm not over time. So I'm an associate professor at the University of Lisbon. I'm in Technical, which is the engineering school of the university. I'm also the vice president for the board of the Interactive Technologies Institute. So this is an institute that houses not only faculty from Technical, but also from fine arts, design, psychology. So we have quite a large group of cross-disciplinary projects at our institution. Within the Interactive Technology Institute, I lead the HCI lab, so the Human-Computer Interaction Lab, which amongst a lot of different things, we of course do research in AR and VR, otherwise I wouldn't be here. So we work on cross-reality collaboration, cross-reality interaction, using biosensing to augment people's emotions so that they could facilitate or not face-to-face communication, as you see there. So we color-coded people's emotion and try to sort of augment their expression. We've used augmented reality to control smart devices like smart lamps. And we also have some studies characterizing user performance with augmented reality while mobile. Again, just a small summary, sort of introducing myself before I actually start with the talk. So again, this is my students. A lot of the work I'm going to present here is actually from other institutions. Some of the work is from our own researchers. So if you want to know more about our group, you can just sort of scan the QR code, or you can just Google my name. It should be easy enough to find our work. Okay, so before I start, I think most of you know what is the research method, but just so we're all on the same page, I'm just going to give you a very, very quick rundown of research, right? So you have an hypothesis, and this could be very academic, or if you're in a company, it could just be my new iteration of the user interface is going to lead to more user retention or user performance or user satisfaction. So you build an hypothesis. It could be quite pragmatic, or it could be quite academic. You then design a study to sort of verify that your hypothesis is not true. And this could be, again, A/B test between the two versions of an interface of a product. And then you collect the results. If the results are good, you sort of iterate over your user interface. If you're an academic, you publish your results, and you let people know about your new findings. Straightforward, sort of building blocks. This talk is going to focus specifically on actually designing and running experiments. One more slide about running experiments. So again, you can run them in the lab. So again, you try to minimize confounding factors. You have a lot of control. You have a systematic way of repeating sort of exposure to an interface, an experience, a system. Or you can run a study in the field. So either people bring your prototype with them, and then they need to report back to you, or you go out and observe people interacting with systems. Again, there's a lot of confounding factors at play here, but you observe also really interesting and probably more ecologically valid responses to a system, to an interface. So again, the pros and cons are quite obvious. Lab studies, you can control a lot, but there's still some artificiality that might affect your results. Field study, very hard to do. You either need to be chasing people around, or you need to have a very complex way of collecting data. But they're more ecologically valid. So what you observe is more true to what your system would affect, so how it would affect people's interaction with it. Okay, so these are just sort of building blocks for this talk. Why am I talking about the research method here at United XR? So VR, again, I love this quote from Gibson. Again, the idea that we might not be talking about VR and AR much longer. This is going to be quite natural, and there's no point in talking about things that are natural. And the question I ask myself, and other researchers are asking themselves as well, is can VR, if people can experience different realities or could be immersed in very realistic scenarios. Can VR help us cross this boundary? Can we actually run lab studies equipped with VR and have some of the benefits of field studies? And the answer seems to be yes. So there's a couple of research trends that you see here that describe this effect in different ways. So some people describe it as virtual field studies. Some people describe it, and by some people I mean Professor Simeone, which is here in the front row, as immersive speculative enactments. Some of us also describe them as virtual reality user studies. So the idea here, of course, there's some nuances between them and how do you apply them, but the end goal is the same, is really using sort of VR to bridge what you can do in the lab and what you can do in the field study. And it's actually goes over a bit more than that. So, okay, so we have some names, sort of get a sense of where we're going. The rest of the talk is basically me describing a couple of case studies, so publications, not only from my group, from various researchers. On the practicalities, on the feasibility of actually doing this, right? So I have a couple of case studies I want to talk to you about that cover some of these some of these domains. So the first one, the researchers were, again, they were not trying to do, they were not trying to validate VR as an alternative to field study. They were just trying to see, if I build a physical prototype, in this case, something very simple, a pepper mill shaker that tells you using lights if it's full, half full, or empty. So you know that when you go out and you go to the grocery shop, if it's yellow, you already know you need to buy some more pepper or salt. And they wanted to know, is there an effect on the way we actually test these things? So if I test it as a video or I test it as a lab, in a lab setting, will I actually get different results from participants? Which again, a big question, right? So they studied these 5 methods. They wanted to see, again, how people rated these shakers in terms of usability and attractiveness using sort of standard questionnaires. Myself, I was just looking at this paper as a way to check, is VR enough? Do I actually need to ask my students or companies to actually physically prototype things in order to test them in the field or in the lab? Or can we actually use VR and get sort of the same results? So again, having a light blink in VR is much easier than doing it with physical computing. It's not hard with physical computing, but again, you need to prototype these things. There's e-waste that comes out of that. So my look at this paper was with this lens. Is VR enough? And again, usability, there were no significant differences. Again, if there's any people statisticians here in the room, this is not the same as saying that they are the same. But for the sake of this talk, these are sort of the way I'm representing the results. So there are no significant differences between the VR condition and the in situ condition. So the condition in which people would have to bring the device home, so they had to be prototyped in a way that sort of worked okay-ish. They had to bring the prototype home, and then they would have to report back to the researcher. So is VR enough to replace sort of this effort? So in terms of usability, there was no obvious differences that we could see. In terms of attractiveness, they have sort of a pragmatic and hedonic scales in this sort of questionnaire about attractiveness. Again, no differences that we could see. Significant differences, again, not the same as being the same. The actual lab condition, where again, you had to prototype the thing, actually led to the worst results. So actually prototyping the thing was an effort that wasn't particularly, resulted in particularly great results. The researchers also measure how quick people could answer the questionnaires, the word count in open questions, and again, no real differences between VR and the in situ condition that required a physical prototype. So this was exciting, so there was some potential here. I'm going to just jump this. If I have time, I'll come back to this use case. I'm going to just start from here. Apologies. So in this second paper, the researchers were more focused on this objective. So they designed a study where you had a public setting with a public display and then an equivalent in VR. They really wanted to see the delta between the two, or the effects of running something in reality or in a virtual setting. Again, they were looking at known effects from public display interaction, like the display blindness or the honeypot effect. And as you might expect from the previous slides, so again, this effect of honeypot happened in both settings. A honeypot is when you see people around the public display. As a social animal, you feel sort of attracted to what people are watching, and you want to see what's happening. So they observe this effect in both VR and in real life. In terms of display blindness, the way they measure this is that you see here they had an additional display, and when they finished the experiment, they were instructed they could continue to interact with the public display, and the experimenters actually took a bit of time on purpose before they would go and pick them up. And they wanted to measure if people noticed that there was another display, and if they went there and interacted with it. And most did. So most exhibit this sort of the similar behavior in the public setting and in the real setting and in the VR setting. Of course, there were some slight differences that come from actually using VR. Again, maybe because of novelty effects, people were more interested in exploring the VR space. It was cool, it was new, they'd never been in, or they rarely been in such a space. Because it's all digital, they were also quite aware they're being recorded, which is, again, with a public display in a public setting, it might be easier for people to forget that there's a camera around. And they had fewer opportunities to be bored. So people in the real setting, when they were waiting for the researcher to come back, instead of actually noticing this, they would just took out their phones and started playing with the phone, which they couldn't do so easily in VR. But these results are quite interesting, motivating, and this is a work that really looked at this contrast. I don't want to say for the first time, but it was one of the papers that were quite resonated with me at the time. So moving from here, the next work is not so much about comparing VR to real life. It's just running a study that you couldn't run in a field study, or it would be ethically very challenging to run in a field study. So this is from one of my students. And this is a study of a system to mitigate gait challenges. So again, if you have Parkinson's, it affects gait or affects how you move in space. And if you read the literature on how to address Parkinson, or so how to address gait limitations or gait effects, one solution that's quite popular is those yellow stripes, or some stripes. So when people see those stripes, somehow they seem to be able to follow them and then have a gait that is more standard. Of course, this is great in the lab. I can put stripes on the floor, and I can show that people can walk more effectively. And you'll find a lot of publications with those photos, people just stepping on yellow lines or lines. But how do you do it in reality, right? I don't want to, even with augmented reality, of course, now with spectacles or one of these glasses we've been interacting with here, of course, you could display it on the floor, right? But again, if people are attending to yellow bars on the floor, will they miss the red light when they cross the street? Will they miss the passing car, the passing pedestrian? So again, very obvious research question. Will these yellow bars work in a scenario where they need to attend to competing stimuli? And again, we could do it in reality, but I think it's much easier to actually carry it out in virtual reality. And then we have competing stimuli. We had specifically haptic feedback that worked really well and was quite understudied in the literature. And with this paper, it became obvious that it actually works very well in the field. All done in virtual reality. Of course, again, we measured gaze hits on these targets, A, B, and C, and dwell times. We also saw an increase in mental demands when people had to deal with the with the visual feedback on the floor and this scene. They had to walk down the streets. And what we saw for the haptic feedback, even though there's few sort of results in literature, we saw quite a nice match between what we were expecting. So the haptic feedback that people received was 90% of their normal cadence. So we were able to actually slower the cadence and increase the step length so that people provide more steady sort of precise gaits. So again, just using VR, we were able to sort of study these properties, these sort of visual and haptic feedback in the way it hasn't been studied before. And this leads us to the paper that actually sort of names this talk. Again, there are at least two of the authors here, Professor Alberto Simeone and Rob. Professor Alberto is from KU Leuven, so he's quite close if you want to interact with him about this subject. We also had the support of Catherine Gerling. And this paper on immersive speculative enactments is inspired by design fictions and speculative enactments, and really defines a method to do these kind of user studies in virtual reality in a way that's sort of systematic and clear. So I'm not going to talk about the virtual parent, which doesn't involve technology. It was just exposing teenagers, and Adal, correct me if I'm wrong, sort of exposing teenagers to taking care of a baby for the first time. Again, you could do it in reality with an observer in the room, but at the same time, we know that the observer causes an effect on the person being observed in studies. So much safer to do it in VR. Your ethical review board will love this methodology. They will stamp your ethical approvals very fast. And then we had this project on the postcard from Mars, in which we were exploring communication between a human base in Mars, the delays in the communication, how that affected the communication and people. So I'm just going to talk about the middle ones, which are about systems, so probably easier to explain. So the first was on this idea of hybrid classrooms. So imagine a future where you're a speaker, like myself, you have smart glasses, and you can see a remote audience in the same place as the physical audience. I don't know if you've ever taught a class, especially during COVID or after COVID, in which you have some students on Zoom and then some students in the classroom. And it's quite stressful and cognitively demanding to be attending to the Zoom students and to the local students. So we wanted to see if the technology exists, and again, immersive speculative enactments allows us to imagine technology that's very hard to implement or even impossible to implement. In this case was the idea that we could have people sitting together, like avatars sitting together, taking physical space in a classroom alongside other students, and that they would track the speaker. So their gaze patterns actually matched in the physical space. I could see if they're looking to me, they're looking to the slides, because that's a very powerful cue to a speaker if someone is looking to them or to the slides. And we wanted to see, okay, let's imagine that technology exists. People can be sort of displayed in 3D space. Their gaze will match natural gaze. So again, using this method, we were able to do that. And also has this sort of methodological challenge. So having a study where you have a classroom of students behaving in a systematic manner across conditions will be very challenging. Recruiting these participants will be very challenging. So again, these avatars are just computers. The way we dealt with gaze was quite simple and smart. Again, at every X amount of time, the gaze had a 50% probability of shifting between the speaker and the slides. So you would feel the audience had a naturalistic but systematic sort of behavior. We had two variables. We had layout. So this is one of the variables. The students were either split, the remote and the local, or they would mix. So we had one variable, and then the other variable will be the actual representation of the remote participants. I have a small video. I think I still have time just to go very quick to the video. Again, the idea here is that the person is simulating an augmented reality experience. So they need to put on glasses. Again, we had to use this not very elegant, but very high contrast UI to represent augmented reality information so that everything else is reality, or they have this idea that they're interacting in reality. They can choose their slides. Again, we're trying to build this sort of believability about the experiment they're going to start. So they need to let the students in. So they see sort of the remote students being beamed in. The remote students have that sort of their names and the sort of the muted icons we're familiar with. And then participants, the speaker, would have to explain the plot to the audience. And we're just sort of measuring their gaze. Are they looking more to what they believe are the co-located students? Are they looking more to the students that are described as remote? So this is a representation of our avatar. So that's the co-located students, the real students that are inhabiting the same spaces as the speaker. And then we varied those three representations for the remote students. And you can see the zoom. So the zoom uses the realistic avatar, again, to make this all more believable and sort of that link between reality and being sort of collocated with the students. Again, we started to see some useful results when the system is possible. For example, if we split the students, so collocated and remote, you actually are going to attend more to the collocated students. Seems like somehow people sort of gravitated towards what they believed were either realistic or collocated students. The realistic remote students led to higher spatial presence on behalf of the speaker. People looked more often to the realistic remote student than to the Zoom student. Again, some actual pragmatic, very simple results, but very pragmatic results when you can actually build a system. There's a reason now to put the effort in to move away from Zoom, because we know that speakers would benefit from having 3D representations of remote audience members. And again, would it help to spend a few more computing cycles to have them look a bit more human than the cartoonish red one in the middle? It seems so. But again, we had the cartoonish one in the middle just to, again, explore if we could have a very low computational demanding experience and still get the benefits of that sort of having 3D avatars out of Zoom into space. So this was one use case, this was master thesis, very simple project, just to show, using this immersive speculative enactments, the kind of studies you can do. The next one is also very simple. We wanted to do, let's imagine again, another future that is not possible, but we can test it in VR. We can interpret dogs' needs. We can represent them as speech, or in this case as an icon, if they're hungry, if they're thirsty. And then we had a very simple question. Okay, where would I represent this information? Would it be in the dog collar? Would it be in the smartwatch of the owner? Fair question. I believe so. So again, this kind of method, this immersive speculative enactment, it allowed us to pretend the collar existed that measured the dog's needs. And then also the methodological difficulties that would have, again, we would have to have a dog that behaves in a systematic manner to have a comparison that's fair. There's also some ethical concerns. We don't want to put the dog in a situation where his needs might not be attended to. So again, here is a virtual dog. Your IRB will stamp the study very quickly. And again, the findings, I'm quite sure almost everyone in this room would know the results, right? So first, the metrics. So usability, time to look at the device after a change in the dog's state. So when the dog goes from happy to sad, we had around 6 states for the dog, if I'm not mistaken, and the number of gaze hits on the interface. And I'm just going to show you a video. So participants were instructed to do just general chores in the house. So there's a virtual house. They had to clean, throw out the garbage. And as they're doing this, they're getting these prompts that the dog needs something. And they're getting it condition A in the collar, condition B in the watch. Very simple A/B tests. But actually very quick to do in VR, very simple to do. And no dog was harmed in the making of this research project. And now to the results, which I'm assuming you're going to guess. Again, people notice the dog's change in needs faster in the smartwatch. In terms of usability, it wasn't clear that they favored one or the other, but they looked faster and they looked more often to the smartwatch. So once this technology exists, we don't need to start from scratch. We already have some data that tells us, actually, this can be, we don't need to build a very sophisticated collar. We can just have a smartwatch or a smart glass display this information. This would be another condition we would want to test. Okay. So I'm just going to leave this paper here, invite you to interact with it, consider it when you're engaged in R&D. The point of these kind of methods is to produce more ecologically valid lab studies. So these are all lab studies, but they have this veneer of a field study. It also goes against this, again, we're facing this crisis of replication in academia. A lot of papers, you can't reproduce the results in the lab. This invites people to do this replication, especially when they do the comparison with the real study. And again, it would be great to download the study as a Unity application, right? If I actually want to run or increase a condition in, for example, in the dog study, I want to add the smart glasses condition. If I could just download the study as a Unity app, run it, it would really, again, I think this is good for academia, it's good for researchers, for participants. And it's really exciting that you can actually test formally, systematically, impossible or very improbable systems. It saves you time and gets you interesting results that you can use in 5, 10, 15, 20 years. So last slide again, if you didn't get a chance to scan the code, you want to have a look at some of our other work. Thank you. I think I have 1 minute for Q&A.